Hello everyone, today I'll be talking about forces and matter.
First and foremost, forces can change the shape and the size of objects. Tensile forces stretch an object, bending forces causes the object to be bent, torsional forces an object to be twisted, compressive forces compress an object. There are springy objects that will come back to their original shape once the force has been removed. For example, when a football is kicked, it becomes compressed due to the compressive forces applied by our foot. But after the force is removed, it comes back to its original shape. Some less springy objects like rubber ropes, which are used in bungee jumping, become permanently stretched and they stop suddenly at the bottom. Also, metal panels of cars bend permanently after collision, and gold and silver objects are deformed when you hammer them so that they can be shaped into beautiful ornaments. A spring is designed to stretch a long way when a small force is applied. To investigate the stretching of a spring, hang the spring from a rigid clamp so that its top end is fixed. Hang weights on the end of the spring so that it stretches. These weights are also known as loads. The lengths are measured by a meter rule and always from the same ends of the spring to ensure fairness. You observe that as the load increases, the length of the spring increases in proportion. When the load is increased too far, the spring becomes inelastically deformed. It means that it will not return to its original length. It has reached its elastic limit. From the data that we have observed, we can plot a load extension graph. This extension is the increased length of an object when a load is attached to it. Let's take an example observation table in which we add loads, measure the length and calculate the extension. By finding out the difference between the initial length and the extended length. When there is no load applied, the length is 24 cm. Since this is the initial length, the extension is 0. When you apply a load of 1 Newton, the length becomes 24.6 cm. So the extension is 24.6 minus 24, which is 0.6 centimeters. When you will keep increasing the loads applied to it, you can plot a graph where the load is the y-axis and the extension is the x-axis. At first you can see that the graph slopes up steadily. The gradient is constant, but then the graph curves after a particular point, because after that any load added is great enough for permanent damage of the spring. After investigating this, the Hooke's law was discovered. At a certain point, which is also known as the limit of proportionality, the steepness of the graph will decrease. At first, the steepness was constant, but after this point, it decreases. The spring will not return to its original undeformed length. We can conclude that the extension of a spring is directly proportional to the load applied to it, provided that the limit of proportionality is not exceeded. Thus, F, which is the load applied, is equal to K into X, where X is the extension of the spring and K is the spring constant. K is the force applied per unit extension of the spring. It is a measure of the stiffness of a spring. K will be bigger if a bigger load is required to the same length of spring. If K is bigger, the spring is stiffer. How can we determine the Hooke's law using an experiment? Using a boss and a clamp stand, we can hang the spring. Masses can be hung from bottom end and the top end can be kept fixed. Meter rule can be used to measure the length. Firstly, arrange the ruler so that 0 cm is at the top end. Draw a table as we saw before. When there is no load, record the reading of the ruler where it lines up with the bottom of the hanger. Record the new ruler readings for each load and calculate the extension. Plot a straight line graph which passes through the origin but then curves after the limit of proportionality is reached. A safety precaution will be using eye protection because the spring can fly into the ice if it breaks under tension. Rubber shows an unusual behavior. Even though bigger the load that is added to the rubber material, the bigger the extension is. Graph drawn is never a straight line. It is an S-shaped curve as the load is not exactly proportional to the extension. Eventually, an increase in the load will produce no extension because the rubber has become very stiff. The rubber will not come back exactly to its original length. What is pressure? The force that acts per unit area at right angles to the surface. Mathematically, force upon area, SI unit of pressure, is pascals, and 1 pascal is equal to 1 Newton per meter square. In a fluid, the pressure that is exerted on an object depends on the amount of fluid that is above it. Thus, as the depth of an object in a water body increases, the pressure on it will also increase. Submarines have to have curved surfaces that are made of thick metal so that they can withstand the high pressures, the depths of the oceans and seas. Higher you go in the atmosphere, the lesser the amount of air is pressing down on you. Therefore, atmospheric pressure on a mountain is much lower than on the sea level. Saw examples of water and air, which are liquids and gases. Since they can flow easily, they are known as fluids. This fluid pressure also depends on the fluid's density, and it acts equally in all directions because the particles in a fluid can move around freely. To calculate fluid pressure, we need a different formula, as we just saw that it depends on the depth of the object in the fluid. On the density of the fluid, we can derive in a formula pressure is equal to depth into density into acceleration due to gravity. This means that the pressure of a fluid is directly proportional to its density, object's depth, and also to the gravitational field strength. Thus, when we make dams, the base is the thickest because the pressure of the water is greatest there. A thicker base needed to withstand that high pressure. Crucial to note that when you find the total pressure exerted on an object in a liquid, you need to add atmospheric pressure, which is 1 into 10 to the power 5 pascals, to the pressure of the liquid itself, because the liquid is below sea level. So, air is above it in addition to the amount of liquid.
This was all about forces and matter. For more videos like these, subscribe to my channel and press the bell icon. Thank you.